Hello everyone, you are watching NPTEL Chemistry E-class and here is Chemistry Detective to solve your Chemistry class 12th NCERT exercise problem 2.8 which is from your unit 2nd, that is solutions. So our problem is, we have an antifreeze solution comprising of two components, ethylene glycol 222.6 grams and water 200 grams. Now we have to calculate molality and molarity of this solution if its density is 1.072 gram per ml. Antifreeze solutions are used in car vehicles in order to prevent freeze of fuel there in the liquid, there in the engine. And this antifreeze used in engine is basically a solution, binary solution comprising of ethylene glycol and water. Respective weights of solute ethylene glycol and solvent water are given. Now using these weights of solute and solvent, we have to calculate first molarity of solution and then molarity, and density of solution is also given. So problem is based on concept of molality first. Molality, and molality is represented by capital M. Molality is the number of moles of solute dissolved in 1 kg of solvent. In 1 kg of solvent, number of moles of solute that are dissolved is termed as molality. And molality is equal to ratio of number of moles of solute and mass of solvent in kg. Number of moles of solute I may represent by N2 and mass of solvent I may represent by W1 expressed in kg. This is the basic equation. This is the fundamental equation of molality of solution. And this equation is a proof of fact that molality is method or unit of expressing concentration of solution. It is the relative amount of solute present in given amount of solvent, or it is the amount of solute present in unit amount of solvent. Now identify amount of solute is expressed in terms of moles and amount of solvent in the denominator is expressed in terms of its mass. Thus evidence that it is the relative concentration. It is the method or unit of expressing concentration of solution or relative amount of solute present in solution. Now if I may express weight of solvent instead of kg in grams, then I will write N2 divided by W1 expressed in grams. But this ratio on RHS side is the number of moles of solute present in 1 gram of solvent. it is not equal to molarity unless I multiply it by 1000. Now RHS side of this equation gives me number of moles of solute present in 1000 grams of solvent, which is equal to 1 kg of solvent and which is equal to molarity. This is one more equation of molality. This is one more equation of molality. And number of moles of solute is not measurable property of solute. It is better to express number of moles of solute in terms of measurable property of solute, which is mass, because what we can take from the bottle in which the solute is present available in the lab is mass, not the number of moles. So here I will express number of moles of solute in terms of its available mass, and the exact equation that relates moles with available mass is number of moles of solute will be equal to available mass W2 and molar mass M2. I will substitute now. I will express N2 in terms of W2 and M2, and the equation I will get is I will write here M is equal to W2 multiplied by 1000 divided by M2 multiplied by W1 but in grams, weight of solvent but in grams. This is the applied equation for expressing molarity of solution, and in this equation all the parameters are parameter related to solute, that is W2 is mass of solute which is measured, which we can measure or weigh on balance. M2 is molar of mass of solute which we know, which we can calculate from its formula, and W1 is mass of solvent. Similarly for molarity, molarity is number of moles of solute present in 1 liter of solution, and the applied equation for molarity is W2 weight of solute multiplied by 1000 divided by molar mass of solute multiplied by volume of solution but in ml. This is the applied equation of molarity, and this is the applied equation for molarity of solution. I will apply these two equations in order to solve this problem. Given is weight of solute ethylene glycol. Weight of solute ethylene glycol is given to 222.6 gram. Weight of solvent water is also given equal to 200 gram. Density of solution is also given 1.072 gram per ml. I need these given parameters for substitution on the RHS side of these two equations, so I wrote these parameters. I will use first molality equation. Molality is equal to weight of solute, which is 222.6 multiplied by 1000 divided by molar mass of solute, and solute is ethylene glycol C2H6O2, and for ethylene glycol molar mass is equal to 62. We need to add atomic mass of 2 carbon, 6 hydrogen and 2 oxygen, and it comes equal to 62 multiplied by weight of solvent in grams, which is 200. And after evaluating RHS side of this equation, I will get molality of this solution is 18 moles per kg. This is the molality of this equation, and information it conveys is this, that 18 moles of that 18 moles of ethylene glycol are dissolved in 1 kg of solvent water in order to prepare its antifreeze solution of molality 18. Similarly, I will calculate molality. Molality is equal to available mass of solute, which is 222.6 multiplied by 1000. Molar mass of solute ethylene glycol is 62 multiplied by volume of solution in ml. Instead of volume, but volume of solution in ml is not given. Instead is given density of solution, and I know the total mass of solution, which is 422.6, equal to mass of solvent plus mass of solute. And I also know that density is equal to mass by volume, ratio of mass and volume. I need to find volume. Volume will be equal to ratio of mass and density. Both mass of solution as well as density of solution are known to me. I will substitute instead of volume, ratio. Volume of solution I will express in terms of ratio of mass of solution and density of solution. 222.6 multiplied by 1000 divided by 62 multiplied by mass of solution, which is equal to sum of mass of solvent and available mass of solvent and solute. It will come equal to 422.6 divided by density of solution, which is 1.072. And molality of equation, after evaluation, molality of equation, I have already evaluated this value. Molality of solution comes equal to 9 mole per liter, and the information is that when we take 222.6 grams of ethylene glycol and 200 grams of water, actually we are preparing its solution of ethylene glycol in water of molarity 9 molar, which means that in order to prepare this solution, 9 moles of ethylene glycol ought to be dissolved in 1 liter of solution, or I may say 1 liter of solution will contain 1 liter of this antifreeze solution will contain 9 moles of ethylene glycol. But if you are able to observe, in order to find molality or else molarity, I needed to do homework, and homework was I needed to evaluate RHS side of molality equation and RHS side of molality equation, in which I needed to multiply, divide digits or numbers. And you know that in NEET JEE exams, calculator is not allowed there, so you have to train, you have to practice multiplication, division, square root, cube root, log, antilog, solving quadratic equations. So that basic mathematics, I mean, you have to practice basic mathematics. You don't need to use calculator right at the start, because prepare yourself for what you have to face at the end. At the end you are without, in exam you are without calculator, so train yourself without calculator. Practice multiplication, division, and with time your speed will increase, and in exam you will be able to find correct answer, and that too within 1 minute, because you need to solve their one objective in 1 minute, and for that you need to have idea, recall idea, you need to do chemistry part of the problem, you need to solve chemistry part of the problem, and then you need to solve the mathematics part of the problem, which is usually second last or last step. So have that in mind as well. This is what I have got today for class 12 students. See you on Tuesday, because Monday is reserved for class 11th. Thank you. Take good care of yourself. Allah Hafiz.